Hello, algebra students. Are you ready to get on the freeway? We'll be solving multi-step equations. And I have some good news and some bad news. The good news is we're not really learning much new today. What we're going to be doing is putting together all the skills we've learned so far in algebra in order to look at some of the most challenging examples you're going to see. The bad news is a lot of times when you're putting together a lot of skills, you get them mixed up. So I always compare solving multi-step equations to the first time you get on the freeway. You practice all these various driving skills, one at a time in a slower arena, and now all of a sudden you have to use them all really quickly. And it can feel frightening. And so you might feel that today, that little bit of overwhelm. But just like after you drive on the freeway for a while, it becomes second nature. The same thing's going to happen with these solving multi-step equations. The more you work on them, the less you're going to have to think so hard about each step. We are going to do this together. You're going to be okay. And it's not just me here with you. We've got Miss Annette, one of my favorite students of all times. She's here to make sure that I make sense. Let's get started. First thing is, we've spent a whole lot of time already this unit talking about the difference between simplifying and solving. Today, we're going to put the two together. So I want to make sure that we really have them straight so we know when we're using which and how. So Annette, if I say to you, simplifying versus solving, any thoughts?
Well, Kate, to be honest with you, I've always had an issue with simplifying and solving.
Do you mix up the two?
Right.
Yeah, you're not alone. That's exactly the issue that most struggling students have. So let's really lay it out clearly today. So simplifying, first of all, that is when we're obeying the symbols. When it says add, we add. When it says multiply, we multiply. We simplify expressions. For example, 2x plus 6x can be simplified. We can obey this symbol here. We can simplify. 2x plus 6x, that is 8x. And 8x means exactly the same as 2x plus 6x. It's just a little simpler. Now, when we started solving, that's when we started seeing some interesting math. In fact, it's kind of the first time in math we started being disobedient. Up until we started seeing solving, you guys were always obeying the symbols, but all of a sudden I started saying, don't do what it tells you to do the opposite. Use inverses. So solving is when we're looking to isolate our variable so we can know what it's equal to. We cannot solve an expression. Over on the other side where it says 8x, I do not have the power to figure out what x is. All I could do was simplify it, and it's just going to sit there being a mystery. But it was the day that we got equations that we said you can start to be able to solve. Now, I am going to qualify this because equations are not the only thing we can solve. In fact, next class, we're going to see inequalities, another thing we can solve. So I'm just going to say, and other relationships between expressions. We can't solve until we have relationships. We want to have clues. For example, 2x equals 6x plus 40 is an equation. I have an expression equal to another expression. I know the relationship between these two expressions, so I have the clues that I would need in order to solve this. When we are solving, we're working to isolate our variables. We actually don't obey the symbols. We actually use inverses. So we isolate our variable using inverses, and we say that that's only legal if you keep the left and right hand side balanced, equivalent. So I will often say that equations and inequalities are two-sided. Whatever we do to one expression, we're doing to another. Again, it's just that idea of having our balance. So for example, if I had 4x plus 6 is equal to 10, and I wanted to solve this, start isolating to get the letter alone, I would do the opposite of what the symbol says, and I would do it to both sides or both expressions. Now, on the other hand, I am going to go ahead and call this one-sided. You look at each piece separately, not an equation or an inequality as a whole. Today, we're going to be seeing examples where it's an equation that has expressions within it that can be simplified. So let me give you a super simple example. So it's an equation. I'm going to be able to solve it. But remember, all an equation is an expression equal to an expression. And so if one or more of those expressions can simplify, well, simplify it. 2x plus 4x, it's straightforward simplification I can do. If I have 2x's and I add 4x's, I end up with a total of
6x's.
Beautiful. And now look at that. 6x's is equal to 18. I'm done simplifying. There's nothing more I could do on the left or the right-hand side, but I can now solve that. I can work backwards on both sides to get the letter alone. I can see those two worlds, those two big algebra worlds of simplifying and solving, conjoining, coming together today as I mix them up. So one more thing that I wanted to remind you about simplifying versus solving was how it affected the order of operations. Simplifying, that's when we worked the order of operations forward. We did groupings first, then dealt with any exponents and their inverse, the radicals. Then we dealt with multiplication and division, and finally addition and subtraction. And so I would like to introduce you to the lovely algebra twins. We are going to call this sweet, obedient little girl GEMA. She does what she's told. She makes life simpler, and she goes in that nice order, GEMA. However, welcome to her mischievous twin sister, AMEG. AMEG's so fun, she spells her name backwards. And I want to thank GED instructor Isosa Oshodi from Ohio, who introduced me to AMEG, a little trick that she uses with her students. AMEG, she kind of does the opposite of what she's been told. She likes to work backwards, but you know what? She's a real problem solver. So we're going to utilize both the twins today as we work. So a couple things I want you to notice. You see how GEMA just stays on her side of the fence. She's just over there all sweet and kind, following directions and making life easier. But little Miss AMEG, she's tunneling under the fence. Anytime you want to cross an equal sign, that's when we need our solving skills. Are you working on one side or are you crossing the equal sign? The second you start crossing the equal sign, that's when we're disobedient. That's when everything works backwards. That equal sign is that fence, and it's only Miss AMEG who crosses the fence. Okay, so I'm going to give you 3 wisdom principles for solving multi-step equations. These are not rules. You have a lot of freedom when you have equations. You literally have the freedom to do whatever you want, as long as you keep those left and right-hand sides equal. But just because you're free to do things doesn't necessarily mean that they're wise. My sweet daughter just turned 18 and she's like, I'm able to do all kinds of things. And you know, moms over there like, these aren't all wise things, okay? The first wisdom principle is that simplifying. Little Miss GEMA, bust her out first. Goodness, if we can make something simpler, let's do it. So we are going to simplify the expressions if possible. Now remember where the expressions are. We've got an expression on either side of an equal sign. So if we can simplify the left or the right-hand side, or sometimes both, let's do it. That's little Miss GEMA, who does what she's told and stays on her side of the fence. So I'll give you an example. In a case like this, you can see that I have an expression on the left-hand side and an expression on the right-hand side. The right-hand side can't get any simpler, but the left-hand side sure could. I know how to obey that sign. I know how to add 2x and 6x. So I could make this equation simpler. 8x equals 32, and it would mean the same thing. Second wisdom principle is when we have variables on both sides. Get the variable terms to the same side. I will remind you that terms are things adding or subtracting. And so this is always done through addition or subtraction.
Just one question. Does it matter if the equal side is on the left or the right-hand side?
It's not that the equal sign is on the left or the right-hand side. The left and the right-hand side are either side of the equal sign. The equal sign is the fence. So I'll give you an example. Let's imagine that we had an equation where the equal sign was there. This is a different scenario. This doesn't have a left or right-hand side I could simplify. If you look at the left-hand side of the equal sign, that's just 2x. I can't multiply together 2 and x if x is a mystery. And if you look at the right-hand side, GEMA can't help us now. There's no way to make 6x plus 32 any simpler. I can't do that addition because they're not like terms. Now's when I would have to start moving across the equal sign. GEMA stays on her side of the fence. But as soon as you want to start flipping back and forth across the equal sign, that's when we're using Little Miss Contrary AMEG, doing the opposite of what she's been told. And then finally, if you handle both of those issues, the simplifying and getting the variable terms to the same side, that's when we're going to start that process that we're used to, where we start isolating the variable. We know that when we're isolating the variable, we are moving across the equal sign. So just like we've been doing, we're busting out Miss AMEG. We're using inverses on both sides. So is this a lot to remember? Well, yeah, it is. That's why I want to spend the whole class today practicing this over and over again and using these 3 wisdom principles. So you start getting that familiarity with it so you don't have to think so hard every problem about when you're doing what. And for those of you who still struggle after this video, the mathability that I've made for this one does it like 30 more times. So you can just do it over and over again with me until you feel comfortable driving alone. Let's start with our beginning level examples. So first example, solve 72 equals 15p minus 9p. My ultimate goal is to find out what p is equal to. However, now's the time for the twins to play nicely, because GEMA can help us out before we bust out Miss AMEG. We have an expression on the left-hand side of the equal sign. That one can't get any simpler. It's just a number. There's nothing I can do there. But if I examine just the right-hand side, there is a way to make that simpler. We know how to do 15p minus 9p.
6p.
Exactly, it's 6p. Now, we were obedient. We did what we were told. That stays on one side of the fence. It does not affect the other expression. Wisdom principle number 1, we said, was simplify the left-hand side and the right-hand side, if possible. But now you can see we're done with GEMA. We're done with that simplifying process. Our left-hand side, we're already just a number. There was nothing to do. And if you examine the right-hand side now, I can't make that any simpler. I can't times 6 by a mystery p. The best I can do is have them shoved up together like they are. This is as simple as it's going to get. Now it's time to bust out AMEG. We need to start moving things across the fence, moving numbers across the equal sign. And so now we are going to isolate the variable. Now you might be thinking, why'd you skip your second wisdom principle? It's not coming up right now. I don't have letters on both sides. And now you can see I just have a simple one-step equation. We know how to isolate the variable to solve this. We're isolating. We're moving across the equal sign. Now we're not doing what we're told. We're doing the opposite. It says 6 times p. Little Miss AMEG says, heck no. You said multiply. I'm going to divide. And not only does she do the opposite of what she's been told, she always does it on both sides. There she goes tunneling over the fence. And that's why we needed the little problem solver. Beautiful. Now let's see what my new equivalent equation will be. Well, multiplying by 6 and dividing by 6 are opposites, so p's alone, just like we wanted. And now that AMEG got that number on the other side, we can simplify it. And so now we know that 12 is p. And yeah, can you write it this way? It doesn't matter, you guys. 12 equals p, p equals 12. They mean the exact same thing. I'm not concerned with which way you write it. Example 2 says solve. And we see something that might look a little scary, but stop with your fraction trauma. Calculator's going to handle that. We just have to know when we're simplifying and when we're solving. when we're obeying the symbols and when we're disobeying the symbols. This says 3/4 times the quantity of 20t minus 12 equals 36. Our first wisdom principle that we said is simplify this sucker if you can. If you can make the left-hand side or the right-hand side any simpler, do it. Now, this is a really good time to use boxes or even cover one side of the equation with a piece of paper, because when we simplify, it's just one-sided. Examine this left-hand side. Are there any symbols I can obey?
Distribute.
Exactly. I can do the multiplication here. A number times a grouping. So we're distributing, we're multiplying, and I'm going to do the 3/4 times 20 in my calculator.
15.
Beautiful. But it's not just 20 we were multiplying by, right? It was 20t. And so I will have t. And now, as Miss Annette said, we are distributing that. 3/4 has to pass out to every term in the grouping. So now I need to do 3/4 times -12.
-9.
Beautiful. 15t minus 9 on that side. Now examine the right-hand side by itself. Can you make that any simpler? Well, no, of course not. That's just 36. It's not getting any simpler. This is my new equivalent equation. Now, ask yourself again, take a look at this side. You can see if GEMA's of any more use to you. Can you make this any simpler? Well, no, I can't do that subtraction. Those aren't like terms. I'm done simplifying. Now it's time to work to move things across the equal sign. We're about to cross the fence. That means we are going to use opposites on both sides. And notice what I did first. I dealt with the addition subtraction. Why? Because it's little Miss AMEG. She does everything backwards. We are going to deal with our addition subtraction first. We're undoing math, so everything moves backwards. So subtracting 9 and adding 9 are opposites. They cancel. What's left on the left-hand side of my equation?
15t.
Beautiful. And then on the right-hand side?
That's 45.
Gorgeous. And we are not done yet because the letter's not alone. We're still moving across the fence. So we need little Miss AMEG using our opposites on both sides. 15 and t are multiplying, so I do the opposite. I divide, and then I keep my balance. And let's see what our new equivalent equation will be. Multiplying by 15 and dividing by 15 are opposites. They cancel. What do I have left on the left-hand side?
Just a t.
Beautiful. And then on the right-hand side, there's the math to do.
That's 3.
All right, and now I'm done. T's alone. What does t have to be to make that original equation true? T has to be 3. All right. Now, I just wanted to point out that we've actually seen problems like this before. This is not new for us. We've kind of been simplifying before we solved when we were in geometry. So let's look at how this is the exact same skill. So a rectangle has a length of 25 millimeters and a perimeter of 82 millimeters. Find its width. Oh, guys, I saw length, width, perimeter, and I was like, hey, what do I need right now? The formula sheet. All right, Miss Annette, how can the formula sheet help me out here?
The formula is P equal 2 length plus 2 width.
Beautiful. That is the perimeter of a rectangle formula. And it relates the length, the width, and the perimeter of a rectangle together so that I can solve for any one of them. Now we know when we're using formulas, we've got to plug in any known values. So I'm going to go one letter at a time. First thing I see is a capital P for perimeter. Do we know the perimeter of our rectangle?
Yes, it's 82.
Beautiful. So instead of writing P, I'll write 82. And I keep my equal sign nice and steady. Never move your equal sign. That fence doesn't move. We move across the fence, but the fence stays steady. Number, I still have a 2 here. And next letter I see is L for length. Do we know the length?
25.
Beautiful. It's 25 millimeters, and the 2 and the L are shoved together, meaning they're multiplying. So I will give myself some parentheses there, and I know it's 2 times 25. Don't lose any symbols. We have a plus. Don't lose any numbers. We have a 2. And now next variable I come to is a W. Do I know what my W is?
No.
No. So it's just going to stand in there as the mystery. Beautiful. So I put in the information that I know. And now I would say to you, there's some simplifying I can do here. Examine the left-hand side and the right-hand side of this equation. Do you see any symbols you can obey?
2 times 25.
Exactly. So go ahead and do it. Make your equation simpler?
That gives me 50.
Beautiful. So I'll write 50 under 2 times 25. Now I haven't done anything with the plus 2w. My equal sign stays steady. That fence does not move. And there's nothing to do on the left-hand side. That's just a number. Check that right-hand side one more time. Is there anything else that we can do?
No.
Okay, we're done with little Miss Gemma. She's been real sweet. She made our life simpler, but she's of no more use. It's time to tunnel across the fence, start throwing things on the other side of the equal sign. Now's when we need Miss AMEG. We are going to do the opposite, we've been told, in the opposite order on both sides of the fence. And so we have got to start with anything adding or subtracting with W. So be careful. A lot of times people say, well, that 2 is adding. It's not adding with W. The 2 is shoved up against the W. But the 50 is separated from the W with a plus sign. That's what I need to get rid of first. So I need that 50 to zero out. So I have nothing adding or subtracting with 2W. And so I'm going to subtract it. It's kind of like I'm throwing it over to the other side of the fence. And let's see what my new equivalent equation will be. Well, 50 minus 50, that's nothing. It's 0. I just have 2W left on the right-hand side. Now my fence stays steady. Never move that equal sign. That's your solid ground. Don't let that thing start dancing on you. And then there on the left-hand side, that's the math to do.
32.
Beautiful. Now I'm not done. The letter's not alone. The opposite of multiplying is dividing. And of course, when I'm disobedient, I keep my balance. Let's see what our new equivalent equation will be. Multiplying by 2 and dividing by 2 are opposites. They cancel. W is alone just like I wanted. And 32 divided by 2 is
16.
And now I'm done. The letter is alone. I know what my width is. This sentence says in the language of algebra, 16 is the width. 16 what? Well, I was up in millimeters, so it's 16 millimeters. Let's look at example 4. It says solve 20x equals 15x minus 45. Examples like this are one of the reasons that I tell you, you have got to be real clear about what's the left-hand side and what's the right-hand side. Where's the fence? It's the equal sign that separates the left-hand side from the right-hand side. Examine the left-hand side. I can't simplify 20 times x. And then you examine the right-hand side, 15x minus 45. Again, I can't do that subtraction. They're not like terms. So as much as I would like little Miss Gemma and her straightforward, obedient ways to come and make my life a little simpler, she's of no use to me right now. Yes, the first wisdom principle is simplify the left-hand side and the right-hand side. But remember, I said, if possible. Unfortunately, it's not always possible. I can't start solving yet either because I have a problem. There's an X on the left and there's an X on the right. The second wisdom principle is get the variable terms to the same side. What I want to do is take one of those numbers of X's and move it across the fence. Now you can see that on the left-hand side, I've got just some number of X's, but on the right-hand side, I have some number of X's and a plain old number. So I'm going to take the X's from my right-hand side and I'm going to move them across the fence. Now, a lot of times your first instinct, don't write this down. I'm going to put it in red so you know it's wrong. Students will tell me, well, I'm going to divide 15. No, 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 no. I'm moving the 15 and the X together. I'm not breaking up the multiplication yet. I'm going to subtract away that entire 15x because that entire 15x is a term with the thing I'm taking it away from, minus 45. That's going to make that 0 out. Now you say, can I do that? I've never moved x's before. I've told you a long time ago, you could do whatever you want to an equation. X is just some mystery number. So if we can move regular numbers, we can move mystery numbers. But you can only do it if you keep your balance. Come over here and don't just write minus 15. Make sure you write minus 15x. We have to do identical work on both sides in order to keep our two expressions equivalent. Little Miss AMEG can move anything you want as long as you keep the two sides equivalent. And now let's see what our new equivalent equation will be. Now the 15x is over there with the 20x. Now they're on the same side. Now I can combine them. What is 20x minus 15x?
5x.
Beautiful. And that's going to be equal to, if I have 15x's and I take away those 15x's, I have nothing for 45 to subtract from. It's like you have a zero balance and you spend $45. Well, guess what? You're going to end up $45 in the hole. I just have that negative 45 left. And now your variable has picked a side. We only have the letter on one side. Now we can isolate the variable. And of course, when I'm moving across the equal sign, I use opposites on both sides. Multiplying and dividing by 5 cancel x's alone, just like I wanted. And what is negative 45 divided by 5?
Negative 9.
Gorgeous. And now x is alone. Example 5, solve. Y plus 14 equals 4y minus 4. And again, my first wisdom principle is if you can make either the left-hand side or the right-hand side simpler, do it. But remember, give yourself a visual clue so your eyes don't jump across the equal sign. When we're simplifying, it's one-sided. So examine just the left-hand side. Can I make that any simpler?
No.
Examine just the right-hand side. Can I make that any simpler?
No.
But I do have an issue. This is not a straightforward equation quite yet, because do you see that I have a y on the left-hand side and a y on the right-hand side?
Yes.
Now it's time for that second wisdom principle, which is get those variable terms, those letters, to the same side through addition or subtraction, not division. There's a variable term on this side, y, and there's a variable term on this side, 4y. And a lot of times students are like, which one should I move? It actually doesn't matter. Whichever one pleases you. You could move the opposite of the one that I do. And as long as you use your inverses correctly on both sides, you'll get the same answer. But I'm lazy. I like pretty math over ugly math. And so I kind of try to avoid negatives if possible, especially knowing that my students have more transcription errors when negatives get involved. I think what I'd like to do is move this guy. I'm going to subtract this y away. Now, why did I want to do that? Because I look over at that right-hand side and I see that I have 4 y's. It's going to be nice and simple to subtract a y away from that. Notice how I jumped all the way across the equal sign.
When I see one variable by itself, I'm always thinking towards the invisible one.
Oh, yeah, I can do that. That'll help us to subtract. But the second thing I want you to notice is where I wrote the negative y or the negative 1y. Look who I lined it up with. I put the y term right underneath the y term because I know I can only add and subtract like terms, and I want to do myself a visual favor. If it's unclear who it's under, you might get unclear who it's adding or subtracting with. Now let's see what our new equivalent equation will be. Well, if I have just the 1y, just the y, and I take it away, there's nothing left there. That's nothing adding with 14 or just 14. And then 4y minus 1y is
3y.
Brilliant. Now, careful. Sometimes students will drop stuff. You still have this minus 4 that you didn't touch, you didn't affect. Now the variables picked a side, like I like to say. So now we can work to move the numbers over to the other side. We're going to isolate that variable. We've put it over there on the right. Now let's make sure it's the only thing on the right. And again, of course, when I'm moving things across the equal sign, we are using opposites on both sides. And it is a little miss a meg, so we'll move anything adding or subtracting first. Let's take away this 4 that's subtracting by doing the opposite, adding 4. That's legit. I can do it as long as I do it to both sides. Subtract 4 and add 4 are opposites. They cancel. So now I have nothing adding or subtracting with 3y. I have just 3y. And that's going to be equal to
18.
Beautiful. Is y alone?
No, 3y.
Exactly. I got another number to get rid of. How could I get rid of that 3?
Divide by 3.
Brilliant. And I can do that. I can be disobedient as long as I do it to both sides. I'm tunneling across that fence. Let's see what my new equivalent equation will be.
6 equals y.
Beautiful. One more beginning level example. So wisdom principle number 1, simplify, if possible, the expression on the left-hand side and or the expression on the right-hand side. Do yourself a visual favor. Use your line, use boxes, or even use a piece of paper so that you're only looking at one side at a time. Simplifying is one-sided. So I'm just going to look at the left. Do you see any straightforward math you know how to do?
Distribute the -5.
Exactly right. What is -5 times x?
-5, x.
Beautiful. And now remember to keep your sign with you. As you multiply, I treat any minuses like negatives. So that's -5 times -2.
+10.
It is. And so I'm going to write +10. And that's going to be equivalent to, examine just the right-hand side. Can I make that expression any simpler?
Wouldn't that be 5x?
Beautiful. Wisdom principle number 2 is get the variable terms to the same side. Do I have letters on both sides?
Well, yeah, there's letters on both sides.
They got to pick a side before I can move the numbers away. But I like to avoid negatives. And so I think I will move that -5x. Now, remember, I'm taking the whole term. I'm not dividing by -5 because I don't want to leave the x behind. And so I'm adding or subtracting. And of course, I can do whatever I want, even if it's a funky something, as long as I do it to
the other side.
Exactly. Subtracting 5x and adding 5x are opposites. They cancel. So what's going to be left on my left-hand side now?
It's going to be 10.
Exactly. But now look at the right-hand side. That doesn't cancel out. 5x plus 5x.
That's 10x.
Exactly. Well, now we can isolate the variable. When I'm taking things across the equal sign, I use opposites on both sides. Multiplying and dividing by 10 are opposites. They cancel. X is alone just like I wanted. Now, don't tell me 10 divided by 10 is 0. That's not true. What's 10 divided by 10?
Is 1.
Gorgeous.
But why wouldn't it be 1 on the other side as well?
What's the invisible coefficient?
1.
When we cancel out multiplication or division, we're leaving behind one of the variable, just a single variable. And since it's just one of them, we just write x. There's no reason to count to 1. I mean, I don't do it in life. I don't walk around going, Annette, this is only one table. You'd be like, Kate, I can count to 1 by myself. Well, I'm done. The letters alone. GEMA and AMEG played nicely together this time, and we got our problem solved. All right, if you're a beginner, we're done. Go on with you. If you feel like you're ready to try this by yourself, go to the beginning level practice, do it independently. Use the solution playlist if you need it. But if you feel like, Kate, will you come drive next to me? Go do Mathability. That's what it's for. I'm going to do it a billion times till you're so sick of my voice. You can't even stand it anymore. But the good news is when you get stuck on the test, you'll have my voice in your head, which is what I wanted all along. And for those of you who are like, that's too easy, Kate. All right, let's step it up, y'all. Experience level number 7. It says, without using your calculator, determine which value of the variable will make the equation true. The biggest mistake students make on this problem, which most of you guys make it, is because you neglect to simplify. Examine the left-hand side. Is there any simplifying I can do over there?
No.
No, R is a mystery. How am I going to square them? Examine the right-hand side. Is there any simplifying I can do there?
3.
Beautiful. Now that's going to be equivalent to, you said I couldn't make the left-hand side any simpler, so it's still going to say r squared. Now you can see there's no more simplifying I can do on the left or the right-hand side. We certainly don't need wisdom principle number 2 because the r is only on one side. So it's time for 3. It's time to work to get the letter alone. So what's the inverse or the opposite of square?
Square root.
Beautiful. So I'm going to take the square root of the left-hand side. Now, for you experience level students, you can handle this little piece of information. For the rest of you, if this is too much, just let it roll over you. But you will need to know for college that there's actually 2 answers when you take the square root, a positive and a negative answer. But they always avoid the negative on the GED, either by using multiple choices or by putting in a context where negatives are not allowed. So you don't need to know that, but I do just want to prep you for that so you don't go to college and say, kids never taught me that. But take a look at what happens now. Square and square root cancel r's alone. And then on the other side, I have this square root of 3. Annette, do you know what the square root of 3 is?
The square root of 3. No, but I can look it up on, oh, we can't use our calculator.
Exactly. We can't use a calculator, but you don't want to anyway. If you tried to type the square root of 3 in there, 3's not a perfect square. You're going to get an ugly decimal that goes on and on forever. And if there's anything pure mathematicians hate, it's an ugly decimal. We love beautiful, exact things. We would say, oh, the answer is just the square root of 3. I can't make that any simpler. without nasty decimals, I'm just going to leave it right there. Just the way we'll leave a fraction right there, we can leave a radical that doesn't simplify right there. And there is my correct answer. Now, that was my only experienced example. So you experienced students, go off, do your thing, go do some math. I'm going to be practicing these same skills on the advanced, but I'm mostly giving you a little peek at what it's going to look like in college. This particular example, you might have to do one of the skills on the GED or the other, but you probably wouldn't have to do both until you reach college. Let's take a look. 5 times the sum of a number and 3 is equivalent to 9 less than 7 times the number. And then it says, find the number. That's another way of saying solve. But what's the problem here? Well, they didn't write the equation for me. They didn't put it in the language of algebra. They put it in English, which means we've got to write an equation. So notice it says 5 times. And when we reach algebra, I told you don't use times signs anymore. Use parentheses, because parentheses are stronger than just time signs. They can multiply and group. We don't know if it's a grouping yet. Let's keep reading. 5 times the sum of a number and 3. That's a grouping. What does sum mean, Annette?
Addition.
Addition. So they're telling me to add a number and 3. That's why I say that's a grouping. There's a lot to put into this parentheses. Now, I don't know the number. It's a mystery number. You know what I need? I need a variable. Pick one for me.
Well, I'm just so used to Mr. X.
We're always trying to find our X over here. I don't know what our issue is. We should let him go.
We should let him go.
And we didn't just have that number. It's not just 5 times the number. It's 5 times the sum of a number and 3. Boom. Now that 5 is multiplying by the whole sum. See why I need parentheses?
Yes.
Beautiful. Now I did this part. 5 times the sum of a number and 3. Now look at this. Is equivalent to. What symbol are they saying to me?
The equal sign.
The equal sign. Now, here's where the trick is. So warning, 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 watch out. 9 less than 7 times the number. That's what we want on the other side of the equal sign. But a lot of students do this wrong. They say 9 minus 7 times the number. That's incorrect because 9 less than means you're actually subtracting the 9. You're taking 9 away from something. So flip those two for me.
Oh.
9 less than 7 times the number means I'm going to have 7 times the number and take 9 away from that. Less than is an order flipper. It means subtract that number. Well, now I wrote the equation. Now I can use my algebra skills to solve the mystery. Let's bust out wisdom principle number 1. Examine the left and right hand sides separately to see if there's any simplifying I can do. 5 times the sum of a number and 3. Can I simplify that, Annette?
Yes. That's 5x. 5 times positive 3, 15.
Beautiful. And it's positive 15, so I'll write plus 15. And the right-hand side, is there any simplifying I can do there?
No.
I agree. Wisdom principle number 1, done. Wisdom principle number 2, you better make sure that your letters have picked a side.
They're not together.
I need to do some work to get them together. Now I'm jumping across equal signs now, so it's time for opposites. But let's remember that when we're moving terms, it's always through addition or subtraction.
I would move 5x.
Sure, let's do it. That's a positive 5x, so I'm going to subtract it away. Negative 5x. My goal is to get it to 0 out. Make sure you get all the way across that equal sign. X's combined with other x's, so I'm going to put minus 5x under the 7x. Now let's see what our new equivalent equation will be. Well, you took that 5x away.
Plus 15.
Exactly. Nothing plus 15 is just 15. And look at the right-hand side. Now those terms are on the same side. Now I can combine them. What is 7x minus 5x?
2x.
Beautiful. And I haven't done anything or changed anything on that minus 9, so it's still minus 9. Wisdom principle number 2, done. I got the letters to the same side. Now, yay, I can start isolating that variable by doing opposites on both sides. And now, of course, I am moving across that equal sign on the last 2 steps. So it is little Miss AMEG. So I'm going to do the order of operations backwards. Let's move anything adding or subtracting first. Let's take that subtract 9 by doing the opposite. Now I can do whatever I want. I can be disobedient, but only if I
Oh, you have to do it on both sides.
Beautiful. Get all the way across that equal sign. Let's add 9 on that left-hand side as well. Now let's see what our new equivalent equation will be. What will I have on the left-hand side?
24,
Beautiful.
my equal sign, and then 2x.
Beautiful.
Well, I can divide by 2.
Brilliant. And what's my new equivalent equation going to be?
12 equal x.
Good. Example 9. A student made an error when solving the equation below. In which line did the error occur? Okay, a little trickier to find someone else's error than to solve our own equations, since there's often more than one right way to go. So I would just recommend that you really examine from line to line what they did, because they're only going to show you each equivalent equation in the work. They're not going to show you the balanced change like I usually make you do. But nonetheless, let's take a look at it through the lens of those wisdom principles. So look at just the left-hand side for me here. Compare it to that line of the student's work. And let's try to figure out what they did. Were they simplifying or were they solving? Well, it looks like they were simplifying to me. Those two are equivalent expressions. They passed out this 3, distributed it, and made the left-hand side a little simpler. So let's check their work there. 3 times 3p is 9p. Nice job. 3 times -1 is -3 or -3. So that side looks good. Was there simplification that could happen over there? Well, yes, same thing, distribution. So let's check their distribution. -2 times 5 is -10. And -2 times -p, remember that's like a -1p, would give me +2p. So that looks good. No error in line 1. Now looking from line 1 to line 2, we can see there were some significant changes. Originally, I had both a p term and a constant term, a plain old number, on both sides of the equation. And now I only have p's on one side and constants, plain old number terms, on the other side. So they must have moved the p terms to the left and the constant terms to the right. So let's do the same thing. So constant term here is -3. So I'm going to do the opposite. I'm going to add 3, and I'm going to keep my balance by doing that underneath the constant term on the other side. And let's check their work there. Subtracting 3 and adding 3 cancel, and I see no constant terms on the left. That looks good. -10 plus 3 would give me -7. That looks good too. Now let's look at moving the p term over the other way. Looks like they did both in the same step. So the opposite of adding 2p would be subtracting 2p, and then doing that to both sides. Ooh, found the error. 9p minus 2p should have given me 7p, and they put 11. It looks like they fell victim to the common student mistake of combining terms across an equal sign without using inverses, without using opposites. So the student's error was in line 2. Number 10. A hollow rubber ball can hold 435 cubic centimeters of water. What is the radius of the ball to the nearest tenth of a centimeter? What are they asking me to do or to find, Annette?
Radius. Well, would it be the circle?
It definitely has to do with circular things. So let's think about that. Even though they don't use a shape name, they describe it. What are we looking at here?
What is the radius of the ball?
The ball. We need a shape name for a ball. So a circle is similar to a ball, but a circle is two-dimensional.
A sphere.
Wonderful. So we're looking to find the radius of a sphere. But we have sphere twice on the formula sheet. There's both the volume and the surface area formula. So we need more information than just it's a sphere to know which formula to use. What else do we know?
I'm thinking volume.
Yeah. What clues can we see in the word problem that would help us to know that it's volume?
Cubic centimeters of water.
Beautiful. The fact that it's cubic centimeters. We know volume is measured in cubic units. And then, like Annette said, the fact that it's water, it's on the inside, it's being held. That's what volume is. It's filling a three-dimensional shape. Good instincts. We know the volume of this sphere is 435 cubic centimeters. Gorgeous. Now we know which formula to use.
V for equal 4/3 times pi times radius cubed.
Gorgeous. Let's put in what we know. We said that 435 was the volume. Which letter do we use to stand for volume?
V.
Exactly. So that 435 needs to replace the V. And our equal sign stays steady. The fence never moves. Don't lose your numbers. I've come to pi.
3.14.
Brilliant. Pi is not a variable. Pi is a set number, and Permission from the formula sheet to use the decimal approximation 3.14. Let's use it. Okay, next thing I see is an R. What is the radius? They didn't tell us. It's a mystery. When it's a mystery, we use a letter. So there's nothing to do with R. It's just got to stay there being mysterious for now. Now I have an equation. Let's follow our wisdom principles. Wisdom principle number 1. Do you see any simplifying you can do?
Well, I could multiply 4/3 times 3.14.
Yep. And don't let it freak you out that it becomes an ugly number. We often get ugly numbers with pi.
4.186 and so on.
Good. Now, I don't want to carry all these digits around, but I also don't want to round. So I'm just going to put ... on my paper. So you know I'm keeping the whole number in my calculator. You don't want to round to the very end of a problem. And that was this piece, but I still have something
435.
on the left-hand side. Yep. And how about on the right-hand side?
I still have the radius cubed.
Beautiful. We've done all the simplifying we can do. We only have an R on one side. It's time to start solving. Now, remember, when you're solving, we need a little Miss AMEG. You're going to move anything adding or subtracting first. Well, there's nothing adding or subtracting with R. Then you're going to move anything multiplying or dividing. Is there anything multiplying or dividing with R?
4.18.
Exactly. The 4.18, yada, 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 however long it is shoved up against R cubed. It is multiplying. To get rid of it, I'm going to divide by that whole long, ugly number. And I can do whatever I want as long as I do it on both sides. To do this in my calculator without dropping digits, I'm going to type in 435. I'm going to press divide, but then I'm going to use my arrow button to arrow up to the long, ugly number. I'll press enter, and my calculator will type it for me. And then enter again, and you should get 103.9, yada, yada, yada. Let's look at the right-hand side. So let's keep our equal sign nice and steady. Multiplying by 4.18, yuck, 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 and dividing by 4.18, yuck, 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 are opposites, so they cancel. So what's left on my right-hand side?
Just the radius cubed.
Awesome. Now, don't make the common student error of stopping here. The R is not alone. We have to get rid of an operation, and we can do it by doing the opposite. But this is one that students often forget what the opposite of cube is. They remember that the opposite of square is square root, but they forget the opposite of cube.
Cube root.
Amen. It's a cube root. It looks exactly the same, except there's a little 3 tucked in the check mark. So if I want to get rid of a cube, I'm going to take the cube root, a radical with a little 3 of both sides. Cubing and cube rooting cancel, so R is alone. But now you have to know how to take the cube root of that long, ugly number. You have to type in 3 first. Then you need the X root function, which is written in green. So to get anything green, hit your green second key. And then you'll see above the little caret button, it says X with a square root symbol next to it, or X with a radical next to it. Hit that, arrow up to 103, press enter to select it, so you don't have to type that whole long, ugly number, and enter again. And we get 4.7, yada, yada, yada. It's now that R is alone that I should round so that I don't lose any information. So go looking through my problem. Do you see any rounding directions?
To the nearest tenth of a centimeter.
Beautiful. So I want my number to end after 1 decimal place, but don't forget to look at what you're throwing away. Let's look at the very next number, 0. I'm not halfway through my digits. That whole thing's going to drop away. And I'm going to say that the radius of my ball is 4.7. Well,
centimeters.
Exactly. 11. The function, okay, that's P of W, not P times W. If I wanted to do P times W, I would just shove them together. This is something special, and I'll explain what it is in a second. The function P of W is equal to 2 times the quantity of 2W minus 5 plus 2W. And it gives the perimeter P of W. So they just told us what P of W means. The whole thing together means perimeter of a rectangle with a length that is 5 inches less than twice its width, W. Oh, they told us what the W means. The W means width. Use the function to find the width of this rectangle if its perimeter measures 56 inches. I just got excited at the end. I was overwhelmed, but then I see what it says. It says use the function to find the width. They're asking me to solve for W. This is a lot easier than it looks. I'll just copy down this equation and use it to solve for W. Now, the hardest part is just getting overwhelmed by what we call the function notation. this whole P of W piece. But they told us what that whole P of W piece means. It means the perimeter. If I know the perimeter, I can just throw that P of W away and put in the perimeter. And guess what? I do. They told me what the perimeter is.
56 inches.
Beautiful. And so your little P of W problem just went away. I replaced it with the perimeter, and that's going to be equal to the other side. Now, W is staying W because I don't know the width. That's what I'm finding. But still, the word problem's gone. That ugly function notation is gone. It's just a multi-step equation now. I never have to look back. I'm just going to use my multi-step equation skills. First thing, do you see any simplifying we know how to do?
Distribute the 2. 2 times 2W is 4W, and then 2 times -5 is -10.
Beautiful. And now be sure to stop your multiplying when your parentheses stop. So that plus 2W is just sitting there. It hasn't been affected by your distribution. And of course, there's nothing to do on the left-hand side. So continue to examine the right. Is there anything else I can do over there?
The 4W and the 2W.
Good. Now, a common error is to try to use opposites here. But notice they're on the same side of the equal sign. So obey the signs.
A 6W.
Exactly. There's no way I can make -10 any simpler, so it'll just drop. Beautiful. Examine that right-hand side. Is there any more simplifying I can do?
No.
Ah, we are done with you, Gemma. We need the problem solver. Out comes AMEG. Let's start working to get the letter alone. Any thoughts?
Well, we need to get rid of something. I'm going to use the -10.
Exactly. I want to bump that -10 on over to the other side of the equal sign, don't I? How could I do that?
Addition.
Exactly. I made a change, so I need to do what?
56 plus 10, and I canceled out those two tens, -10 and +10. That lets me bring down my 6W. 66 equals 6W.
Beautiful.
It's going to be 6.
Adding, subtracting, multiplying, or dividing?
Dividing.
Beautiful. Okay, so I divided by 6 on the one side to get rid of it, and now what do I do?
Now I'm going to have 66 divided by 6.
Beautiful. I'm going to do it on the other side as well.
That's W equals 11.
11 equals W, W equals 11 means the same thing. Don't care which way you write it. But this is a real life word problem, so time to go back to that instead of ignoring it. So I'd like to know 11 what?
To 11 inches.
Beautiful. And honestly, the GED probably won't make you know the unit. It'll probably just be 11, but your teacher's anal retentive and she wants you to know what you're talking about. Okay, last example here. Well, my advanced level students, you are not going to be with me for another unit. At the end of algebra, and we're almost at the end, y'all are going to be ready for the GED. And so I'm going to use this same exact thing we've been doing and showing how it would apply even in a subject we haven't really covered yet, points and lines, but we can do it because it's on the formula sheet and we have formula sheet skills. I'll show you what I mean. The point slope equation of a line, y minus y1 equals m times the quantity of x minus x1, don't get intimidated by all those letters, I'm about to define them, gives the equation of a line that passes through the point x1, y1. So I just told you what x1 and y1 are about. This is the point. A point has an x value and a y value. With a slope m, again, I'm telling you what all your letters mean. The slope is m. Find the equation of a line in slope-intercept form of the line with a slope of -3/2 that passes through the point 4, -5. Oh my goodness, so much going on. But look what they did. They gave us an equation to start with. So before you get overwhelmed, could we just take that equation, pluck it out of the word problem, and drop it down? Y minus y1 is equal to m times the quantity of x minus x1. And this guy is on the GED formula sheet, and it is known as the point slope equation of a line because it gives you the equation of a line when we know the point and the slope. And we know the point and we know the slope. There's the point and there's the slope. So if we know it, let's put it in. Now, the tricky part is knowing where to put the point. But I told you that in the problem. The point is x1 and y1, not the regular x and the regular y in this formula, the x1 and the y1. So I'm going to leave the regular y, and then I'm going to put minus, and I need my y value of my point. So there's my y value of my point. Not +5, it was -5. So this is y minus -5. And that's going to be equivalent to, next letter I see is M. And I know my M. They said my M was the slope, and they told me what my slope was. It's a line with a slope of -3/2. So I don't have to call it M anymore. I can call it -3/2. And that M was shoved up against this grouping. So this -3/2 will be shoved up against the grouping too. And inside the grouping, I see X. Remember to keep the X, X. It's the X1 that comes from the point. And that X1 is 4. And now they told us to do something interesting. They told us to find the equation of a line. We have an equation of a line. There it is. But they tell us to do it in slope intercept form. Now, the nice thing is this is on your formula sheet as well, so you don't have to memorize it. But if you look on your formula sheet and you look at slope intercept equation of a line, what you're going to notice is it says this: y is equal to mx plus b. This is the main thing you need to take away, that the slope intercept form of a line is solved for y. Y is alone. So all you have to do to take this ugly thing from what you have to what they're asking you to find, the slope intercept form, is to get y alone. So let's do it. Looking at the left-hand side, I can make this a little simpler. No, I can't subtract -5 from y because y is a mystery. But I do know that subtracting a negative is the same as addition. And so instead of writing y minus -5, I'm going to write y plus 5. And that's going to be equal to, and examine the right-hand side. There's stuff I know how to simplify. I know how to distribute a number to a grouping. So -3/2 times x is just -3/2 x. And -3/2 times -4, you can do it in your calculator if you need to, but you're going to get +6. And ooh, I simplified both sides. This is looking nice. Y is almost alone, isn't it? There's only one number hanging out with y. Who's over there on the same side as y, Annette?
5.
So I want to get 5 over to the other side. When I want to move sides, I use opposites. What's the opposite of adding 5?
-5.
Beautiful. And I can do whatever I want as long as I do it to both sides. Now look, 5 is not going to subtract with -3/2 x. Do yourself a visual favor and put it under the term it will subtract with. Adding 5 and subtracting 5 cancel. Y is alone just like I wanted. Now, I can't do anything with -3/2 x. It's not going to get any simpler. It's just going to sit there. But I sure can do 6 minus 5. That's +1. And then you might say, oh my gosh, what am I going to do now? You're not going to do anything now. It's what they asked for. They asked for the equation of a line. That's the equation of a line in slope intercept form. In slope intercept form means with y alone. So there's the equation of a line with y alone. This is the final answer. You're done. And you can see how our formula sheet skills and our solving multi-step equation skills come up in even this more challenging context. So now, again, there's a reason why I call it advanced level practice. If you're feeling overwhelmed, it's probably because I told you to stop and you didn't stop. You were like, let me keep going. I wouldn't do this kind of a problem with somebody who's never seen lines before, never seen points before. You're in over your head. But I do want to show you how these very same skills that we've been using apply in all these various contexts. You're going to use it all over the place on the GED and in college. Okay, you guys, you did hard work with me today. I'm super proud, especially if you stuck with me through the advanced level practice. Those were some challenging examples. But I just want to assure you that no matter where you stopped, no matter where you're at, that the struggle is really, really part of the learning. Like we talked about with driving, but now I'm about to mix my metaphors with basketball. You know, for a while we practiced dribbling, and for a while we practiced shooting hoops. And then you play pickup games with your friends in the driveway. And eventually, if you keep practicing and working, you move up into higher and higher levels of being able to compete. Math is the same way. The more you practice, the better you get. So if you're sweating, if it feels like hard work, it's because you're developing muscles. Give yourself a break. Let yourself be in the learning process and stop expecting yourself to be able to jump into an NBA game or ride on the freeway until you practice the skills that go into it. Complex skills take a while to build, and you guys are building them, and I'm super duper proud of you. Happy learning.